Good day, folks. Welcome to my YouTube channel. Today we're going to look at the question of vertical projectile of motion. Let's cut the chase. Now, if you look at it, says a ball standing at the edge of a cliff. A boy is here. Standing at there projects a ball vertically upwards at a speed of 20 meters per second. So a boy is throwing a ball that way, is projecting a ball that way at 20 meters per second. So let's start by choosing a direction. We're going to choose up as positive. Now, on its return, the ball passes a buoy and reaches the ground at the bottom of the cliff 66 seconds after it was projected. So the trajectory is going to be this way, right? That's the motion of the ball. It's going to pass the maximum point, it's going to return where it was thrown, and it reaches the ground there. So now ignore the effect of friction. So one thing that is important that you need to, as the ball moves up, the velocity decreases, and then the velocity there it will be zero, and then this velocity is going to be positive. It's an initial velocity, and then it increases in the negative direction there. So when it passes the buoy, the velocity there it's going to be negative 20. When it passes the same point where it started, it's going to be the same, and then it reached the ground with a final velocity that is negative, but we do not know what is the value. But we know all the journey of the ball while it's in the air, it's 6 seconds. That's very important. And since we chose up as positive, our gravitational acceleration is going to be negative 9.8 meter per second square. Now let's answer the question. The question, it says define the term free fall. Guys, as we know, exam guideline when it comes to a definition, when it comes to a free fall it's a motion of an object if only force acting on it is a force of gravity. So a free fall is a motion in which only force that is acting on it is a force of gravity. Now 3.2, it says give reason give the magnitude and direction of an acceleration of the ball the moment it reaches the maximum height. So we want what is the gravitational the magnitude and direction of the acceleration when it reaches there. So at any point here, guys, the magnitude and direction of an acceleration is what? Is 9.8 meter per second square downwards. Always is downwards at any point, because the gravitational acceleration is downwards. So at any point it will be downwards, right? Now 3.3, it says calculate the time taken for the ball to pass the buoy on its way down. So we want the time that it took from here and it passes the starting point. It started here, so the buoy is here, so we want the time that it take to passes the buoy there. So we want that time. So let's calculate it here. It says 3.3. What do we have there? So which segment are we going to choose here? It's very important. The segment that we're going to choose here, let me choose the entire segment. There are two ways to do that. So I'll choose the entire segment. If I choose the entire segment, this will be my initial and this will be my final. But in my initial is going to be positive 20 meter per second, and my final it's going to be the negative 20 meter per second. What do I want? I want time. And then what do I have? Also, it's an acceleration that is 9.8 meters per second square. And another thing that is important, check my other videos of a vertical projectile of motion. From the starting point and return back to the starting point, the displacement there is 0 all the time. I'm sure you should know by now. So which formula we're going to use there? We're going to use this formula. VF is equal to VI plus AT square, not square. And then my final velocity there, it's negative 20. Initial is 20 plus negative 9.8. Change in t, that's what I want, time. So when I transpose this to this side, it's going to be negative 40 equal to 9.8 change in t. Now when I divide by 9.8 both sides, negative 9.8, so that my time is positive, so the change in t there is 4.08 seconds. Alternatively, what you can do there, you can take this segment only. So that means the time that you're going to get here, you'll times it by 2 so that you can get the entire. So what do you have in this segment? You have initial velocity and the final velocity there. So we use the same formula there. So it's VF, V initial plus AT. So the final velocity, if you take that segment, is going to be 0, which is the maximum point. And where it started, it's 20, positive 20, minus 9.8, change in t. So you have negative 20 if you transpose, minus 9.8, change in t, you divide by 9.8, negative 9.8, negative 9.8. So you have your change in t is equal to 2,04 seconds, right? And then 2,04 seconds you times by 2, so it will be 4.08 seconds. That's the entire time. So the 2,04 seconds is the time from there to there, from the starting point to the maximum point. It's very important to look at it that way. Okay, let's look at the next question. It says 3.4, calculated the height of the ball above the ground 2.8 seconds after it's released. Now guys, this is very important. They told us that the ball, it takes from here to the ground, it took what, 6 seconds, but they want us the height of the ball 2.8 seconds after it was released. Let's assume that 2.8 seconds the ball is here. So what do they want here? They wanted the height above the ground, right? So how are we going to do that? So we're going to calculate the height of the ball from the starting point from there. It's easy to do that. So we don't have the final velocity there. But we have an initial and we do not know the time there. So the first thing that we're going to do there, we can calculate the height of the cliff. The height of the cliff from there to there. Let's start with the height of the cliff, 3.4. I'll show you what I'm going to do with the height of the cliff. Let's say height of the cliff. The height of the cliff, how are we going to calculate it? So the way we're going to do it, knowing that from here to here, the displacement of the ball is only from the starting point to the ground, because the displacement here is what, is 0. When it starts here and it returns to the starting point, the displacement is 0. So the ball is displaced this way, right? So by using the entire journey, which is using the entire time, which is the 6 seconds, it's going to give us the displacement of the ball. So let me write, what do we have first? We have an initial velocity that is positive 20 meters per second. And we have the time of the motion from the starting point to the ground at 6 seconds. The final velocity we do not have. And what else? And we want the displacement, which is the displacement is the height of the cliff. So from those things, so the formula that we're going to use is this. It says delta y vi delta t plus half a t squared. Why are we using this formula? We want the displacement. We have an initial, we have the time, we have an acceleration, we have the time. That's why we're going to use that. So the displacement is the one what we want. And our answer there, it should be negative. It's very important. Why it should be negative? The ball from here to the ground, which is the displacement, because this part is what is 0. So from here to here, it's going to be negative because it's going in the negative direction. So we anticipate our answer. So it's 20 times 6 and plus half acceleration, it's negative 9.8 and 6 square. So when you punch that in the calculator, you get the answer that is 56.4 meters. So it tells you that it's downwards, the negative, it's downwards, right? So now that we have the height of the building, we said that the ball is here. Let's assume at 22.8 seconds, the ball is here. From here, the ball is going to be here. So we wanted the height above the ground. Now we are halfway to the answer because we have the height. Now we only need this part. So in order to calculate the height of the ball now, so what I'm going to calculate now is the height of the ball. Height of the ball now. So calculating the height of the ball, what do we have? It's very important. We still have the initial velocity that is 20 meters per second. And what do we have? We have time. From the starting point to where it is, let's say here, it took what? 2.8 seconds. So we have time. And the final velocity we do not have there at that point. So we have time, it's 2.8 seconds. And the final velocity we do not have. And we want the displacement there. So which formula are we going to use? We're going to use the same formula. So it's change in y. Vi change in t plus half a change in t square. So the displacement is that we wanted the height of the ball. Where is the ball? The velocity is 20 and the time is 2.8 plus acceleration, it's negative 9.8 and the 2.8 square. So if you punch that in the calculator, it says the ball it's 17,584 meters above the ground. So what do we want it? We have this distance now. This distance is 17,548, whatever is it? Yeah, 584, and then we got the height of the building, which is 56.4. So we just add the two. To give us the height. So we'll say the distance or the height of the ball from the ground, it's going to be 17,584 plus 56.4. So the answer there is 73.98 meters. So the ball it's at 73.98 meters above the ground. Now the last question. On reaching the ground, the ball bounced elastically from the ground. So what does it mean, bounce elastically? That means the initial velocity, the velocity before collision is not equal to the velocity after collision. So when the ball reached the ground, the velocity, its velocity when it hits the ground, just before it hits the ground, and the velocity after when it moves up there, this velocity after and the velocity just before, they are not equal. That's why it's elastically. Now it says now Sketch the position time graph of the motion of the ball from the time it's projected and reach its maximum height after the first bounce. Use the top of the cliff as a zero position. Indicate the time on the graph of 6 seconds on the graph. So when they say indicate, when they say use the top of the cliff as a zero position, that means your graph, if you look at this motion, or this motion of the, so that means your Cartesian plane will be there. So your graph, your Cartesian plane will be there, so your graph, it will be like this, your Cartesian plane, right? That's what they mean. So when they say, so this is 3.5. 3.5, here's my Cartesian plane. Alright, this is the top of the building, this is the top of the cliff. So the top of the cliff will be what? 0. So the ball, what happened? It went up and it passes the point again and goes straight down like that, right? And then the entire motion, it took what? It took 6 seconds, right? And then the ball, it bounced, and then it went up, and then like that, right? Like that. Yeah. So that's our graph there. Our graph, it's going to be like that. So the time, this, it's going to be what? 6 seconds. It's going to be 6 seconds, that, because it reached the ground after 6 seconds, right? I hope I make sense.